And there we go. Okay, so hyperbola, let me give you the three different deals. You guys know, like if we have y squared is 4ax or something, that's a parabola branch. And if you have like, change the color here, if you have like x squared over a squared plus y squared over b squared equals 1, that's an ellipse. And then third case, if you have x squared over a squared minus y squared over b squared is 1, that's two branches turned away from each other, hyperbola. So that's the new one today. So I just want to put all three of them before you, just so you can see the general format of the equations for all three. So notice this. Here's a way I remember it anyway that helps me. Notice the parabola only has one branch, huh? The parabola only has one branch. And that's because he's only got one letter squared. The other is first power. So when you only have one letter squared, you only have one branch. When you have both letters squared, you know what it's like? It's like there's two branches that connect in the middle, forming a egg shape, an ellipse shape. That's how I think of it. I just think, hey, we've got two letters squared now instead of just one. So it's like we've got two parabola pieces that connect up and they form an egg shape. And then down here on the hyperbola, the new one, this is the hyperbola, we have two branches, but they have negative in the middle. That's the only difference between the ellipse and the hyperbola equation, is that negative in the middle. The negative in the middle, it makes the branches turn away from each other. They have a negative relationship, let's say. I'm just making up stuff to help you remember. That's what works for me. The ellipse has a positive relationship. They're turned towards each other. The hyperbola has negative. The two branches have turned away, and the parabola just has one branch because it only has one letter squared. So there's the basic look, if that's helpful to you. So let's go on to the particulars. All right, so how do we do it? Well, basically there's two ways the hyperbola thing can go. You can have x squared in the front. And now, by the way, it'll matter who's in the front and who's in the back because they're subtracted now. They're not added. And so if you have x in the front, no surprise, the branches go right, left on the x-axis. And if you have y in the front, then the branches go up, down, because y is up, down. So there's two ways they can go. So if you have x in the front, they are on the x-axis, right and left. And if you have y in the front, they are on the y-axis, the branches going up and down, whichever letter's in the front. And they call that the transverse axis. So the x is the transverse, one word. The transverse just means across. It's just the axis that cuts across. It's the main axis. It's kind of like what they call the major axis for the ellipse. The transverse axis. So they will use that lingo. Okay, so with that in mind, looking at this picture right here, these branches are going right and left, aren't they? So which of these four equations is right? Could it be A, for example? No, because A has the y in the front. It can't have y in the front. That's up, down. So A and C are out, huh? No way. And now it could be B or D. How do we know which one it is? Well, I need to give you a little bit more information. Y'all got that copy down? So it's either B or D, right? How do we figure out which one? So there's a little bit more to it. So let me just guess at B, try B, and see if it's right or not. Here's what I mean. So x squared, what is it? Minus, I'm just going to try B here. X squared minus y squared over 9 equals 1. Notice it's equal 1, just like for the ellipse. It's exactly like the ellipse equation, huh? Just that minus in the middle there is the only difference. Okay, how do you graph it? What number's really underneath x? 1 squared, right? Okay, now when it comes to the graph, let me get this out of the way here. When it comes to the graph, let me graph it over here. When it comes, let's pretend for just a minute that we're graphing an ellipse because it's so similar. It's almost the same thing. If we were graphing an ellipse, this is 1 squared and this is 3 squared, right? If we were graphing an ellipse, we would go, what would we do? We'd go right 1, left 1, and up 3, down 3, right? And put our dots, and then we would just make our egg shape, huh? Y'all with me so far? Am I still coming through? So yeah, whatever's underneath X is right, left. Whatever's underneath Y is up, down. And so yeah, I would just go up 3, down 3, right 1, left 1, and then I would make my egg shape. Okay, but it's not an ellipse. You still need those 4 points, but because it's an ellipse, instead of it's a hyperbola because it has a minus in the middle. Instead of making an oval there, what you do is you make a dotted box. So this is what you're going to want to write down, is this dotted box. So you make a dotted box like that. You ever seen this before? And then you fill in the diagonals. So I'm doing the same 4 points that I would use for an ellipse, the numbers underneath X and Y. That's all the same. But I make a dotted box instead of an oval. And then I go from corner to corner, and I make the diagonal right through the middle. Like that. And then I let it keep on going. Both directions. Like that. And then I do the other diagonal. Corner to corner right through the middle. And let it shoot on past the edges. Like that. You know what those, remember, whenever you put something dotted on a graph, it's not really part of the picture, it's just a guideline to help the graph. That's exactly what those lines are. They're asymptote lines. They're lines that will guide the branches of the hyperbola. That's how we know how wide the branches will open up. So now, this one has X in the front, so it's going to be right, left branches. If it had Y in the front, it would be up, down branches. So X is in the front, right, left branches. So starting right here, and where's it going to go? It's going to go up to here like this and down like that. And so it starts on the edges of the box. See how it starts on the edges of the box? The middle edges. That's exactly where it starts. Like that. So it's pretty wide branches, which is exactly what that picture is. That is the right answer. B is the right answer. If you did D, and you did the same thing for D, you'd find very narrow branches, and you would know it's wrong. So the answer is B. I don't have time to do both. We'll do more. But is that good for now? So the difference between an ellipse and a hyperbola is you make the dotted box instead of the oval. Fill in the diagonals. Those are your asymptote lines. So you know how big the branches are, how much they open up. Okay, so number 3, the center is at 0, 0, focus, and vertex. Okay, so now we're going to try to find the information. Let's put it on a graph. Is always very helpful to us. So the center is 0, 0. The focus is at 10, 0. So I'm going to go over here and put the focus. That's 10, 0. And the vertex, this is at 6, 0. Here, I'll put it right here. 6, 0. Is that good so far? Remember, the focus points are always inside the branches. So what it is the branches are going to go like this, and the focus point is inside, like for all the shapes, huh? Focus points are always inside the branches. And then if one of the vertices is at 6, 0, where's the other one going to be? Back 6, huh? Yeah, totally. Be back 6, 0. And then the other focus is at back 10, 0. Branches going right, left, like that. So there's the two vertexes. How do I know? How did I know these branches went sideways instead of up, down? Well, it's because the focus point and vertex were to the right. So it's just like for the ellipse, you know, wherever the focus points are, that's the main direction of the shape. So the focus points are right and left. So the branches go right, left. Okay. First question is they say, they ask me, which axis is the main axis? X. It's right, left. Their next question is, can you find the equation? I've already got the answer there for you. How did I find that equation? Well, it's very similar. This will be probably pretty easy for you because it's very, very similar to the ellipse, and we've done a lot of those now. Whatever's underneath X is always right and left. So how far right and how far left? 6 squared. It's underneath x. That good? So that's the same as, you know, what you would do for an ellipse. Just right, left is x, up, down is y. But how do we do up, down? We have nothing going up and down. We don't have the dotted box, so we can't tell. So am I going too fast? Everybody with me so far? So right, left is always what's underneath x. Up, down is always what's underneath y. So I don't know up, down. How am I going to get it? Look, I know the focus points. Guess what I'm going to use? Focus equation, again, like we always do, huh? So let's do the focus equation. Now, the focus equation, remember what I said? It's exactly the same, but opposite sign in the middle. So the focus equation will be a squared plus b squared is c squared. C squared, oops, I hit the little button, is the focus. Wow, that's really picky. C squared is the focus up there. Does that make sense? So notice it has plus in the middle instead of minus, right? So for the hyperbola, the main equation has minus and the focus has plus. It's vice versa. So you always have the opposite sign in the focus equation from the main equation, don't you? For ellipse, the main had plus, the focus had minus. Okay, well this is actually really nice. This is easier than the ellipse. Why? Because these guys are added. So I don't care what the order is. I don't have to sweat the details about which one's A and which one's B, worrying about which one's bigger and smaller, because it doesn't matter. They're added, right? The other one was subtracted. And so if things are subtracted, then the order matters and you really care about which one's bigger going first. But these guys are added. So don't even worry about A and B. A and B are just the two things under X and Y. Doesn't matter which is which because they're just added. So that's nice. So, okay, so I'll just say, okay, 6 squared plus B squared, whatever, A, B, whatever, is C squared. Do I know C? What is C? Good, 10, yeah. It's how far from the center. So C, from the center to the focus, 10 squared. Is that good? So that way I can solve for B squared. So let me bring it down here. So 36 plus B squared is 100. Subtract 36. B squared is 64. Root it. B's 8. So there we go. 8 squared, that's how we got that answer. And we're done. Is that making sense there? It's kind of the same as all those ellipse ones, huh? The focus equation has plus, so it's easier. Doesn't matter about the order. Don't have to be careful about which one's A, which one's B. All is well. I'm going to move on. All right, so number 6 here. So x squared over 49, or sorry, x squared over 9 minus y squared over 49 equals 1. Can you start to graph that one? Let me give you a minute on that. I think you'll get more out of it instead of me just jumping in. So go ahead and start the graph on that one. No, make the dotted box. Make that dotted box on that one. So start at the origin, 0, 0. I'm going to make the dotted box. Give you a second on that one. How we doing? We okay? So what is the, when we make the dotted box, what is the 9 mean that's under there? That's 3 squared. So that means right and left 3 for the dotted box. So right 3, left 3, and then this is 7 squared. So that's up 7, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Up 7, down 7. 1, 2, 3, 4, 5, 6, 7. Up 7, and then just make the dotted box. Like that. Like that. And then corner to corner, fill in the diagonals and let them shoot out the corners. Like that. Good, like that. And now, to the branches on this one, do they go right, left, or up, down? Now, how do we know? Remember, it's whatever's in the front, huh? Notice it's not which number's bigger. That's different, huh? For the ellipse, it was always which number's bigger, but for the hyperbola, it's whoever's in the front. X is in the front, so these branches are going right and left. So that means you start in the middle right here. It always starts in the middle point, and you go right and up, and middle, left, like that. So there's the branches. Okay, so there's the general look of the shape. Now they want me to give them all the particular details. So let's get that. So I'll do that. Okay, so let's see. How do we find? What do they want? Oh, what's the the center? The center is just 0, 0, isn't it? So we'll start with that. The center is 0, 0. They're going to move them in a minute on us. Center is 0, 0. Next, they're going to say, what's the transverse axis? What's the main axis? The right, left, the x-axis, huh? What are the vertices? What are the vertices are right here and right here where the shape actually hits the axes. So that would be the point over 3 up 0 and back 3 up 0. The two vertices, like that. And what are the focus points? How are we going to find the focus points? Remember where the focus points always are? They're always inside the shape. So like that, inside the branches, I mean. So those will be focus points right there. And you find the focus points by the focus equation. A squared, this will be plus, huh? Plus b squared equals c squared. And that'll be the focus. So can you do that real quick? So two focus points, like that. And so we've got to find the c. Now how do we find the c? That is a squared plus, so you just go 9 plus 49. Doesn't matter the order or anything because they're added, huh? So we don't have to sweat it. What's that? 58 is c squared. Like that. Root it. And isn't that just 2 times 29? So nothing's going to come out of that root, huh? It'll just stay root 58. No simplifying possible on that. Just root 58 on that. Okay. So that means this is right root 58 and left root 58 on that. So the focus points are root 58, 0 and minus root 58, 0. Like that. And so we got the vertices, the foci. Last thing, the asymptote lines. Am I racing ahead of you? You okay so far? So now, let's find the equation of the asymptote lines. How do we do that? Well, what we're talking about, let's first off be clear what it is we're talking about. We're talking about like this line right here. This is the diagonal ones. Those are the asymptote lines. These are the lines that the graph gets closer to, and the other one also, both of them. These are the two lines that the graph will get closer and closer and closer. You know, that's what an asymptote line is, right? Closer and closer forever. It's a guideline. So what are the equations of those two lines? You know how to find the equation of a line, right? What's the general formula for the equation of any line? Y equals mx plus b, right? Remember that? So the asymptote lines. This will actually be super easy when you think about it a certain way. Let me help you. So mx plus b, wouldn't you agree that's generally how we do any lines equation? And so now what's the b? When you write mx plus b, what is the b? What exactly is the b? The b is the y-intercept, isn't it? Remember when you graph? The b is the center point, the y-intercept, where when you do a graph, if a line starts up at 3 or whatever it is, that's the b. It's where it hits the y-axis. Remember that from your algebra days, what the b is? So what's the b? Where does this one hit the y? It's at 0, huh? So we can just skip the b is my point. The b is just 0. The y-intercept, both those lines go through the y-axis at a height of 0 at the origin. So really I just have y equals mx. This line, let's just do the first one, the one going up. This one has got to be just y equals mx. The b is 0. Goes through a height of 0 here. So what's the m? M stands for slope, right? Remember what slope is? It's rise over run. So all I need is rise over run. Any ideas how much that line rises and runs? Yeah. It's just whatever's underneath y, 7 squared, over what's underneath x. Of course. See how it's just 7/3 x? Does that make sense? This will be super easy because how far it goes up, remember, from the center, right and left is the number under x, up and down is the number under y for ellipse, hyperbola. So rise is the number under y. Well, the number a, before it's squared, the 7, not the 49, but the 7, right? It's up and down 7, right and left 3. So rise over run, slope is just 7/3, isn't it? So you could do that right from step 1 without doing anything. Just whatever. And always under y is always up, down, is always rise. And under x is always going to be your run. Now so this line's equation is y equals 7/3 x. That's the equation of that line. What's the equation of the one that goes down? Negative. So in other words, what we do is we put plus or minus, and we're done. That handles them both. The one going up is plus 7/3. The one going down is minus 7/3 x. So that's really actually very easy. So there's the two asymptote equations. That good? On that, so we answered everything in the world about that thing. Okay, so we'll finish with this one. The center is 6 minus 6. The focus is 9 minus 6. The vertex is 8 minus 6. So yeah, so now they've moved one off the origin. See what you can do with that one. Oh, you know what? Wait a minute. We'll do this one. Okay, try number 13. So put that, we got 5 minutes, 6 minutes, see if you can get that one. So find the equation of the hyperbola. The center is minus 8 minus 1. So back here, or right here, huh? So there's the center, minus 8 minus 1, the center, and minus 8 minus 9 down here is the vertex, or that's the focus, and the vertex is right here. So the branch must be going like that, huh? Everybody see that? Because the branch is always at the vertex, and the focus is always inside, right? Like the receiver's inside the satellite dish kind of thing. So these branches are up, down, aren't they? I want to give you one where the branches are up, down. That's why I chose this one. So these branches are up, down. So see if you can come up with the equation. There's got to be another branch somewhere up here that's going up, huh? Wherever, it doesn't matter a lot to me. Some other vertex branch up here and some other focus point up there, whatever. So let's do the equation. So when I go to write the equation, which letter goes in the front, X or Y? It's going to be Y in the front because it's an up-down, huh? Or minus in the middle. Good, like that. It's got to be something like that. So it's up-down branches. So what do we do from there now? How do we know how far up and down? Because the up and the down will be what goes underneath the Y, huh? Yeah, it goes from -1 to -8, so that must be down 7. Does that make sense there? So this must be 7 squared. Right, the up-down must be 7. Okay, now how do we find the B? Guess what we're going to use? The focus equation, time number 27 today, right? Use the focus equation yet again. So, and it's easier because it's plus for the hyperbola for the foci points, okay? Now, what is the C? How far is it from the center to the focus? From the center down to the focus? -1 down to -9. It's down 8. So this is 8 squared, or -8 squared, same thing. And the a squared, b squared, remember the order doesn't matter because they're added, so who cares? Just make this 7 squared plus b squared, and then you can solve. So b squared is what? 64 minus 49. B squared is, what's that, 15? So we can just replace b squared with 15. We're done. We got the equation. B squared is 15, right? That's not 15 squared. That is b squared, right? So notice b is the root of 15 squared, if you prefer. Or I mean b squared is the root of 15 squared. You know what I mean. I'll just leave a 15 there. And that's correct. Is that good? How we doing on that? Wow, we didn't quite finish the hyperbola. I really wanted to finish that.